Hello, this is Naghmana. So we are doing a Spec Maths exam 1, and we have this is 2021. So we are up to question number 8. Let's see what is the question number 8 says. We have an equation which is where z is a complex number. It's a quadratic equation. We have to solve for it. It's a 1-mark question. So that means should be nice and easy to do it. So let's do that. It's a quadratic. We're going to use the quadratic formula in there. So that would be equal to -2 plus minus 4 minus 4ac, which gives you 8 over 2, and that will be -2 plus minus -4 over 2, and that will give me -1 plus minus I is the answer for this one. Okay, so that's good. And now we have question number, it's a B part of the question number 8, which is worth 3 marks. So this is an indication here is that it's going to be a bit of work. Okay, let's do that. So it says z squared plus 2z bar plus 2 and AB for z is a complex number. So let's say if we have a z look like this, a plus bi, right? This is like a standard way of writing it. And conjugate of that would be a minus bi. And we know that a and b are real numbers. Okay, so now let's sub in there. We get a plus bi squared plus 2 times a minus bi plus 2 is equal to 0. So now we're going to expand these brackets and collect the real and coefficient, then the complex coefficients separately. So we get a squared plus 2ab minus b squared plus 2a minus 2bi plus 2 equal to 0. So that will give me a squared minus b squared plus 2a plus 2. This is a real part. And then I have a imaginary part of it. So which would be 2. We have a 2ab and 2bi. So the 2b is a common there. And then we get, so this is 2b outside. We get a plus 1. Oh, a minus 1, sorry, not plus. So a minus 1 equal to 0. So what does that mean, equal to 0? That means I could say that the real part is equal to 0 and the same with the imaginary part is equal to 0. So I would go a squared minus b squared plus 2a plus 2 equal to 0. And the other one is saying 2b times a minus 1 equal to 0. So what is this is giving us that either b is equal to 0 or a is equal to 1. The second equation suggested that. What happens if b is equal to 0? Let's say b is equal to 0 would give us a squared plus 2a plus 2 equal to 0. So this equation is exactly the same look like in part A of the question, if you look, see. But imagine here we're saying a, b a real number. So that means this has no real solution. This equation has no real solution because we just saw that that is a complex number. Real solution for a, because we assume that a and b are real numbers. So that means we're expecting to have a real solution. Okay, then what does that mean? This is when b is equal to 0. Okay, now check what is happening when a is equal to 0. Okay, so when a is equal to 0, we get to do, and a is equal to 0, we get minus b squared plus 2 equal to 0. A squared and a squared 0. And we're saying a is, wait a minute, it's not 0. A is 1. Okay, so that will change the story. A is not 1, A is 0, A is 1. So this will give me 1 minus b squared plus 2 equals 0. So that means b squared is equal to 5. That means b is equal to plus minus square root of 5. Okay, so what is that give us? That means the complex number z, we were solution for that equation would look like a plus a is 1 plus minus root 5i. So that should be our answer for that question. Okay, I think we're done with question number 8, which is if you just pay a little bit of, see, it was first 3-mark question. This is 1 mark. I think this is pretty good, 4 marks in there. Now we have question number 9. This is the last question in the exam. So, and has a worth of 8 marks. So that is double amount of work maybe we need to do for as compared to question number 8. So let's see how quickly we can get through this one. So we have a position vector r of t is given. The 2 position vectors are given relative to fixed point O of particle A and particle B, and t is between 0 and c, where c is a positive real constant. Show that the Cartesian equation for the path of particle A is this. Okay, so if we look at this A is corresponding to R. If with this, the I component, which is x there, so that is equal to -1 plus 4 cos t, and the y is 2 over root 3 sine of t. So what we need to come up with is something look like this. Okay, so we need to show that the Cartesian of particle is that. So that means we need to show that this is equal to 1, right? So if we do that, so we need to do a bit of the squaring, and so we need to clearly now use that. And we also, because it's a square happening there, we also need to use the trig identity, which we know that is cos square t plus sine square t is equal to 1. Okay, so let's see what we can do. We get x plus 1, right? And then we can divide x plus 1 is equal to 4 cos of t. When I divide that by 4, I get x plus 1 over 4. And then I take a square of that, will give me cos square t. Okay. Now I would do the same in here. Let's see what I can do. I can rewrite it as root 3 y over 2 equal to sine of t. Now we can do is square of this one. This will give me 3 over 4 y square is equal to sine square t. Now we see we got the 2 expressions. So let's give them equation number 1 and equation number 2, and then we do 1 plus 2 give us x plus 1 square over 4 plus 3 over 4 y square is equal to cos square t plus sine square t. And that's the identity we can use. That means this is equal to 1. So we proved that. That's what we needed to show that. Show that means you have to come up with that answer there. That's kind of the equation. Okay, so now we have the same kind of question for equation of the path. Show that the Cartesian equation of path of particle A in the first quadrant can be written as this. So what does that mean? So we got 3y squared. Can I just rewrite that using still the same equation? So I can go and write it like 3y squared is equal to, just take the 3y squared over 4 here, and I get 1 minus x plus 1 squared over 16. Okay, and then we can write it as y squared is equal to 4 over 3, and then 16 minus x plus 1 squared over 16. And then you see what we can do here. I'll make a bit of more room. Okay, so let's see what we can do. So we say y squared is equal to this would be 12. And then we have 16 minus, expanding this bracket will give me xk minus 2x minus 1. and that could be simplified to negative x squared, negative 2x plus 15 over 12, and that is y squared. We need to come up with a, now we take the square root in the first quadrant, that would be, the square root would be, taking the square root of that would be negative x squared, 92x plus 15 over root of 12. So the y has to be in the first quadrant, has to be positive. So we ignore the negative one. So this will be written as negative x squared, negative 2x plus 15 divided by, we can simplify that third and see we can come up with this kind of equation, which is 2 root 3. And then it seems like we need to rationalize that. So that will be 3 root 3 and root 3 over 6, and then square root of negative x squared, negative 2x plus 15. So we just times that by, what we did here is we times this one by root 3 and multiply this by dividing that. So that does not change, but it's give us the final version of that. So that's the answer. Okay. So now the next part of the question is we need to show that the particle A and B will collide. What does that means? We are saying R of T is equal to S of T, or that subtract that equal to 0. So that means we go and write that down. So we have just look at our R of T. So that is negative . Okay, so I just need to write those in front of me so that we can use them. So just going on to the previous page to get that answer for this one. Okay, sorry about that. Just got that in front of me. Now then easy to do it. So we go, or you could write it like that, the subtract equal to 0. So that means this would go into I. So we get negative 1 plus 1, 0. So you get 4 cos of T and 4 cos of T minus 3 secant of T and I. And then we have plus 2 over root 3 sine of T, then minus tan of T is equal to, that's the J component, equal to 0. So equal to 0 mean I could say that 4 cos of T minus 3 secant T equal to 0, or the J component, the coefficient is sine T minus tan of T equal to 0. Now we're going to solve that for T. So we say that will give us what that will give us. So this would be 4 cos of T, and then if we take the sine of T, common factor from there, so you get 2 over root 3 minus 1 over cos of T is equal to 0. If we look at this one, I can rewrite this one as well. So 4 cos of T minus 3 secant is minus 3 over cos of T, right? That is equal to 0. What does that mean now? So we're looking at, so there's a comma in between. So we're looking at now, if we note that there. So we want to find that the both of these equations have what they have. They have cos of t is equal to, if we do that, so that have cos of t. So we can say this give us that is equal to √3/2. And that means t is equal to what? Pi on 6, right? So t give us the pi on 6. So what we are saying is in both of these one, they will collide. So then when we're saying is the both of these particle will collide when cos of t is equal to √3/2, and that give you when t is equal to pi on 6. Okay, so now we have a second part of the question. Find the coordinate of the point of collision of the two particles. Okay, now we need to find out the point. Okay, so from there we know we have a cos of t is equal to √3/2, right? And sine of t is equal to so this will be, now we have to use that r, and so we say t is equal to pi on 6. Okay, so if we go in here, what is the r would look like? So r would be, so pi on 6, cos pi on 6 is √3/2, right? Minus 1. So this will give you minus 1 plus 4√3/2, right? I plus 2/√3 sine pi on 6 is give us 1/2. Sine pi on 6 is 1/2. And that would give me j component. Okay, now let's simplify that. That will give me -1 plus 2√3 I, and then this would be 1/√3 j. Now let's see what is happening to the s. So that will be equal to 3/6 of t, which is pi on 6, will give us -1 is 2√3. So that give us 2√3 minus 1, right? I, and then 10 pi on 6 would be 1/√3 j. If you see that in both of cases, r is equal to s. So that means the point of collision would be equal to 2√3 minus 1 and 1/√3. So that would be our point there. Okay, so that's the part 2 of the question. Now let's see the part C of the question is C1. So we have one more. Okay, so show that the derivative is equal to that. So it's just the differentiation, which is seems like a lot of working in there, but it's not that hard. So you just have to stay focused and be patient. You will be able to do it. Okay, let's do that. So we have a sine inverse x, which you can you know the formula for that. So that will be equal to, so we go left hand side is equal to the derivative of that would be the square root of 1 minus x plus 1/4 square, and then that would be times by x plus 1, the derivative is 1/4, and then you have 8. 8 times 1/4 is 2. And then we go and differentiate the next bit. So we have x plus, this can be simplified minus x squared minus 2x plus 15. Remember that this is the same kind of, we need to use the product rule there, right? So I will like use the product rule. So this will be equal to x plus 1 is the derivative is 1. So that'll minus xk minus 2x minus plus 15. Okay, plus x plus 1 as it is. The derivative of that will be 1/2 minus xk minus 2x plus 15. And then the derivative of the base, which would give me this power -1/2 times by negative 2x negative 2. Yep. Okay, so then we need to see how can we simplify it. So this will become, it's a 4 square, so that will be 16, and that goes up there as a 4, so that give me 8 over square root of 16 minus x plus 1 square. And this would be 1/2 and square root of minus x square minus 2x plus 15. And then doing this will give me -2 x plus 1 square over 2. That's 2 and 2 cancel out. We can take this 2 away over square root of minus x square minus 2x plus 15. Okay, so better I will write that as a fraction, simplify it. So that will be, if you expand this bracket, that will be exactly the same one. We did that just before. So that will be equal to -x squared negative 2x plus 15. Why I'm writing it like that? Because if you see the right hand side is not in this form, it's in this form. So I will better do that. So this will be 1/2, and then that will give me minus x squared minus 2x plus 15 minus x squared and minus x minus 2x plus minus 1 and divided by the minus x squared minus 2x minus plus 15. Okay, so now we see if we can simplify that. So -2x minus x squared, see we can now take the both of these. If you look at that, they have the same denominator, -x squared minus 2x plus 15. Okay, and then we have, and this one has a 2 in there, so that means that's 2 would be in the denominator as well. And this will become 16 plus, and which is, let's see if we can simplify that. Okay, so we just need to do a bit of more working out. So this will be 2 over x squared minus 2x plus 1. Yeah, that's fine. So I'm just trying to think, how can I minus 2x squared minus 4x plus, this should be 14 there. So 15 plus minus 14. Okay, so then let's see what can we do. So we go minus 2x squared, it is equal to minus 2x squared minus 4x plus 2 over, seems like I have made this minus there. There is a sign problem somewhere, I can see that. So this would be plus 15. That's how it is goes. So root minus x squared minus 2x plus 15. So I think I messed up a sign there. So we just need to minus 2x squared minus 2x plus 15. And then we got to do is minus 2x minus 2. I'm just checking, rechecking. Just give me a second there. So we got This is 14. I got it. So 16 plus 14 would be, because there is a plus sign there, so that would be equal to 30. 30. Okay, so that's good. Now we can take a 2 as a common factor out. So we get xk minus 2x plus 15 minus xk minus 2x minus 15 over 2. That 2 and 2 cancel out. And then that means negative 2x plus 15. So that's 2 and 2 cancel out. And then that means I could write that as a minus xk minus 2x plus 15. So that is equal to right-hand side. See, it was a lot of work, and you see it's only 2 marks question, but that's okay. Only the calculation error could happen. Okay, so now we see the last part of the question is, hence find the area bounded by the graph, this, the x-axis and the line x is equal to 1, x is equal to 2 root 3 minus 1 and shown in the diagram. So they've given us the diagram. Give your answer in this form. So that means we are finding what? Area. Area from where to where? So we say from 1 to 2 root 3 minus 1. And we are integrating that. So root 3 over 6, square root of minus 2x square minus 2x plus 15 dx. Okay. So let's do the integration for this one. So that would be equal to root 3 over 6, just come out as it is. If we see that, so that will be negative 2x squared minus 2x plus 1, which is the same as we have started off with. If we go back in a step, so we know that the derivative, this is equal to, we're using the part C in there. Okay, we don't have to do integrate the derivative. We can use this one because we're saying square root of this is equal to d over dx of that. So I'm just going to use that because then d over dx and the integral cancel out each other. What we get is 8 sine inverse x plus 1 over 4. What we did is I'll write it down. So we are using part C1. Okay, so that's what we're using in here. So that will give me x plus 1. And then the next one is just one step back. Okay, yeah, so plus x plus 1 square root of x minus 2xk minus 2x plus 15 over 2. And then we need to put a limit, root 2 root 3 minus 1. And then you go upper limit minus lower limit will give us the answer for this one. So we go root 3 over 6. So 2 root 3 minus 1 plus 1 give you 2 root 3. So you have 8 sine inverse 2 root 3 plus 1, right? Minus 1 over 4. And then we have minus 8 sine inverse of 2 over 4. And then we go plus 2 root 3 minus 1 is 2 root 3. And then inside we sub in this one, so which is easier to handle it because I know this expression, we used that before, because this one, square root of negative x squared minus 2x plus 15 is the same as if I write it like this, 16 minus x plus 1 squared. It's just only because I wanted to do this substitution so that I can easily work that number out. So that would be 16 minus 2 root 3 minus 1 plus 1 squared over 2, and then minus 2 root 3 and square root of 16 minus 1 plus 1 is 2 squared over 2. So now let's see what we get. So we have a root 3 over 6 sine inverse of root 3, which will give us Let's see what we get. 2 root 3 over root 3 over 2 sine inverse root 3. This cancel out. Root 3 over 2 is pi on 3. So this will be 8 pi on 3. And we get 8 pi on 3 minus 1 over 2 sine pi 1 over 2 would be pi on 6. So that is 8 pi on 6. This would give me 1 and 1 cancel out, and that will give me 2 root 3. And this is 2 root 3, give me 4 times 3 is 12. 16 minus 12 is 4 over root 4, which is 2 over 2. Minus 16 minus 4 is 12. So 2 root 3 and root 12 over 2. So let's see if we can simplify that. So that will give us root 3 over 6. 8 pi over 3 minus 8 pi on 6 is 16. So that gives you 8 pi on 6. I just solve these two, and then, okay, so 8 pi over 6. And then we need to work this one out. 2 and 2 cancel out. We get plus 2 root 3 minus, because remember root 12 is 4 times 3, which is 2 root 3. So 2 root 3, this 2 and 2 cancel out. I get 2, which is minus 6. So this 2 and 2 cancel out. I've got 2 root 3 minus 6. 2 root 3 minus 6. Root 3 minus root 12. I think these two has to cancel that out there. So because we get 2 root 3 in there, so this one is root 12. I'm just 1 second. So I was doing that in here is x is equal to 1. I think I just messed it up. So when is x is 1, so there is no root 3 in here. Okay, so that 2 and 2 cancel out. I get root 12. So root 12, and that is the same thing. So 2 root 3, and that is minus 2 root 3, that cancel out. So we get 8 root 3 pi over 36, which is, we can simplify that as, can we simplify that? That should be 2 root 3 pi over 9. Where a and b are positive numbers. So a is, in this case, that's the answer we wanted to. 2 a root 3 over 9, where a is 2 and b is 9. Okay, I think this takes a bit of time there, but you can see that it's okay to look, I'm doing these questions on spot just to show you that it takes a little while to do the question. I'm not doing pre-written solution or anything. Thinking on spot is a skill which all student has to master it. And it's okay to make a little mistake, and that's where we are human. We make mistakes, but calculation error is pretty much possible. That's okay. You can stay calm and complete it. I think you can do that. Thank you very much for listening to me. If you have any questions, please comment below. And if you like this, subscribe to my channel and like the video. Thank you very much.